Okay, so welcome back. And what I want to do in this lesson is to address the issue of avoiding data races. So I think we realize by now that, or I have said it previously, every time a request gets sent to our server, the server creates a Go routine to handle that request. So what's the consequence of that? Well, if we have, let's say, 100 people trying to update a particular school, then we will have 100 separate Go routines, and each of those Go routines will have their own update method to call, their own get method to call. In other words, they'll have their own separate handler. So each of them can call the update method, right? The get method. So how do we coordinate this so that we don't have stale or dirty data in our database, incorrect data? And so that brings up the idea of data race, meaning whichever request gets processed first by the server, then their changes are the one that's going to go in. But that leads to another problem, because whoever comes second, their change will overwrite whatever is in the database. And so if we have all 100, and let's say the 100 request makes their change and that gets written to the database, then what happens? All the previous 99 changes have been lost, right? So that's a data race, meaning whoever gets access to the data or the shared resource first, the shared resource first gets to make changes. So a simple example, if we have a store online and it currently has 3 apples, and so person A buys those 3 apples, okay? Well, the system will specify now that there are 0 apples remaining. But let's say at the same time, person B also wanted to buy apples. So the system would also have done or called the update method at that same exact time. And so that means that person B has 3 apples. That's what they are seeing. They don't know that it's now 0 apples. Okay? And so this has already been written to the database, 0 apples remaining. And so now when the system processes user B's change, whereby it's 2 apples taken away, meaning 1 remains, then this is actually what gets written to the database, right? So the 0 remains gets overwritten, and it's the 1 remains that gets stored. And so we have a now inconsistent database, because we don't have 1 apple, we have 0 apples. And so that's the problem with data races. All right. So we want to fix this so that doesn't matter how many requests we have, we will be sure that the database, when everything is done, will still remain in a consistent state. All right. So let me get rid of this and let's start the steps of ensuring that our web application takes into account data races. Okay, so the first thing I want to do is to, let's say, go to models, okay, and let's come here, okay, and let's create an error that will tell the client that there was some data race that occurred, and so their change could not be made because it would have caused the database to be in an inconsistent manner, right, or state. And so we're going to call that error, excuse me, we're going to call that error edit conflict. All right. And so that's just going to be another error. And the message will be edit conflict. All right. Okay, so that's the error message we will be checking for. Okay, so that's straightforward. Let's now go to our update method. So let's go back to data schools, and let's actually make the query, make a change to the query so that we will be checking to see that what we read from the database and what we're trying to update is actually still relevant. It hasn't changed while we are trying to make changes. Okay, so how would you do that? Well, we're going to do that by using the idea of optimistic locking. Okay, and the idea is very simple. All right, and we're going to do optimistic locking on the version number. So this is what I'm going to do. I am going to read in the version number, of course, and let's say the version number is 1. Well, I know it's 1, and so I'm going to make my change, but before I write the change to the database, I will make sure that the version is still 1. Okay, if it's not 1, then I know that somebody else changed or made an update to that record. Okay, so let me show you how that's done. So we're going to update, we're going to set, right? And then I'm going to say where ID is 9. Okay, and version is the original version that I think it is. Okay, all right, and then returning a version. Great. So this is my query. The only change I've done is that we want to ensure that the version has not changed between when I read it and now when I want to write it back with the change. Okay, and so that's rather straightforward. So here I'm just gonna say school that version, right? Okay, great. So again, the idea is we want to keep a check on the version number to make sure it has not changed. Okay, so this is where we make or we check. So let me go back up. Yeah, so here is where we're going to check. So I'm not going to return anything. I'm going to save this. I'm going to say error is that. Okay, so what I'm going to do, I'm going to check, all right, for edit conflicts. All right, and so I'm going to make my query. All right, make my query, and then of course I'm going to get back version. Now, if I read in the school and it had version 1 from me, and then somebody else, they also wanted to do an update, and so they also had version 1, but then their update was saved to the database, and so now the database will now have version being 2. Okay, and so when I execute my query, the database will say, okay, update schools, where ID is 9, good, and version is 1. Because I am still expecting version to be 1. And then if the database will say, there's no version 1. So the database will return back to me no rows. It cannot find a row, it cannot find a school that has a version of 1. Okay, and so that's what I'm counting on, that if the version has changed, then it means that somebody else did an update. I hope that made sense. Okay, so I have the version read back to me, and so I want to check to see if the version is still the same. Alright, so if error not nil, then it means I have a problem. And so I'll just do a switch, and then I will check to see if I get the SQL that error no rows, which tells me that no row was returned. Okay, no row was returned. Well, if no row was returned, then it means that the version number was changed between my trying to edit the record and trying to save it to the database. Right, so I'm going to return error edit conflict. Right, so that tells me that somebody else made a change, and because somebody else made a change, then I don't want to write my change to the database, because it will make the database go into an inconsistent state, because I will be using incorrect data. Okay. Otherwise, return nil. That means everything went well. Okay. So that's how we will check to see if there was or there is a potential data race. Right. So again, I am doing optimistic locking on the version number. So if the version number changes, then I know that somebody else did an update, and so I will not do anything else, except I will tell the user that, I'll tell the client that there was a change between when you read in or when we call the get and when they're trying to update. All right, great. So that's the second step. And so now what I want to do is to well, before we deal with the updating the handler, let's create the error message that we want to return to the user, to the client, telling them that there was an edit error. Okay. Okay. So let's call this edit error. Okay. And so I'm gonna simply call that edit conflict response. So edit conflict response. And so we're gonna have a message, and the message will simply be the string unable to update the record due to an edit conflict. And so I will just tell the user to please try again. All right, that's it. And so we want to then call the error response method, but we want to pass in the status code of 409. All right, so http dot status conflict. Okay, and that's 409. All right, and that takes care of that. So once we're finished with this, we will now go to our handler. So let's go to API schools.go. Let's go back to our update handler. So where are we? Okay, so our update schools handler. And so all we need to do is to make the change. So when we here we get the row from the database. Good. All right. Okay. Okay. And so we need to come down here when we are about to call the update. All right. So after I call update, then either it works or I get back that edit conflict error. So let's check for that error, that edit conflict error. Okay. So I'm just gonna say case. All right. Again, errors that is. Right. Oops. Switch case errors that is. So we are looking for data.edit error edit conflict. That's what we're looking for. If that happens, then we will simply call the app.edit conflict response WR. Right. Otherwise, we will simply let's see here, make sure. Oh, okay. Let me go back. I realize I messed up. Edit conflict should not be taking all of this, just W on R. Okay, great. So only W on R. Okay, and so the default will simply be app.server error response. WR error. Okay, and then of course when we're done, we will simply return to ensure that no other code gets executed in the update school handler. Okay, and believe it or not, that's it. That's all the change we had to make. And so now our application will be able to handle simultaneous users trying to update a particular school. All right, so let's test this out. So let me start my server. Okay, and so let's see if we can simulate multiple users. So to try to simulate multiple users, I will use the xargs command. Okay, you can do a Google search to find out more about it. The flag in particular is the -p, which says how many parallel processes we want to run. And so I'm going to say 8. So 8 parallel processes. Each process will run this command, curl -x. So it's like simulating 8 users simultaneously issuing the curl command. All right, patch. And let's say the data is simply, we want to patch the name. Okay, so let's say name. Let's say coconut tree. All right. Of course, each user might probably be trying to update it with some other name, but we're more concerned about dealing with multiple users at the same time. All right, so that's the data. And then let's put this in quotes. So localhost :4000 v1 schools /1. Okay, and then we're gonna redirect. We're gonna use a process substitution where we're just gonna use printf to get 8 files. Okay, 1 per process. Modulus s \n 1 to 8. Okay, so that will help us to sort of force 8 processes. Okay. Patch. Okay, patch. All right, let's try again. All right, so, oh, yeah, I think we're at 34. So if I recall, this is 34, not 1. Okay. All right, so we got back 8 of them. So the server was fast enough to be able to do all of them. Let's bump up the number. That would happen if we had maybe 80. Right? Would there be any change? Oh, here we go. Unable to update the record due to an edit conflict. Please try again. Okay. So as you can see, and you know, this can scale. Imagine having a million requests to that one particular resource. It's you know, you're gonna have this, and of course, I'm just using this as an example, right? So the more processes, then we will have the chances of a data race sort of occurring. All right, and so again, all we will do is not write our change to the database, but instead return to the user this message for them to try again. Okay, so that's it. I hope that made sense. Again, the idea is quite straightforward. It's optimistic locking on the version number. It's a very common pattern, and it's used to eliminate the idea of a data race or an edit conflict. Because again, you don't want to have the database be in an inconsistent manner, whereby you can't trust the data anymore. Okay, so let's quickly add this. moved the database bug from the update school handler. All right. Great. So git push -u origin main. All right, and we're done. So I will see you in the next lesson where we will start looking at how we can ensure that our resources are used efficiently. Meaning, if we find out that, for example, we don't need to perform a query, how can we prevent that query from actually occurring and wasting resources? Okay, so we'll talk about that and about the context, the idea of context. All right, so I'll see you in that next lesson.